All right, in the third video in section 10.1, we're going to talk about the graphs of square roots and maybe even the graphs of cube roots and what they might look like and determine their domain and range, what x values are incorporated and what y values are incorporated. So for the graph of f of x, if f of x was the square root of x, so if x is anything, let's see what this graph looks like. Now, the easiest way to figure out what a graph looks like, if it's maybe not a linear graph that we're used to, is making a table of values. I can make a t-chart. I can plug in some x values, figure out what y values correspond with them, plot those different points, and then I kind of see if I can find a pattern. I'm going to pick some x values. I strategically picked some that kind of worked out a little more even so I can graph it more accurately instead of just guessing or estimating using decimals or fractions. So I picked x equals -1, 0, 1, 4, and 9. So that means when x is -1, I'm going to plug it into my function and get the square root of -1. When x is 0, I have the square root of 0, square root of 1, square root of 4, and square root of 9, and so on. And you can do more than that if you need to better figure out the pattern. I just picked a few. Now, the square root of -1. What number times itself gives us -1? Well, remember, there is no number. Anytime I have a negative underneath the square root, I know that I have no solution. There is no way I can ever multiply two of the same number and ever get a negative value back. But the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. So now I have a couple of different points, ordered pairs, that I can plot on my graph. I know I have a point at 0, 0. I know I have a point at 1, 1. I know I have a point at 4, 2. I know I have a point at 9, 3. I can see that none of my x values can ever be negative because there is no square root of a negative value. So it looks like it has to start at 0 and then it's going to go in the positive direction from there. So can I say my domain is from 0 to infinity? So what's my range? Well, it looks like my range is going to be 0, and then it's going to kind of grow slowly and kind of look like this, right? You can kind of even plug in more numbers if you'd like to. The square root of 16 is 4. The square root of 25 is 5. So the x's get really big. The y's still get big, just not as big as quickly. But it's still going to grow, 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 grow. So I can really say that my range is from 0 to infinity. So we can say that the square root of x, that graph, kind of looks like the one that we just drew. You know, I don't know where I got it from, but one of my teachers must have called it a breadstick along the way. So I always say that the square root of x is always a breadstick graph. Starts at 0 and kind of goes up a little bit curved like a breadstick. All right, what about this cube root? I haven't quite talked about those, but a cube root, kind of like a square root, means what number, the same number, multiplied 3 times now to give us the radicand or the number inside. So what times what times what gives me the number 8. You might need to try a few if you need to, or you might need a factor tree until you can break it down into 3 of the same value. But what about 2 times 2 times 2? Doesn't that give us 8? So we can say that the cube root of 8 is really 2. Or what about the cube root of 1? What number multiplied by itself 3 times gives me the number 1? The cube root of 1 is 1. Okay, what about the cube root of -27? You might have noticed that there's a negative underneath. Now, is there a number that you can multiply 3 times to get -27? What about -3? Because -3 times -3 is +9. But +9 times another -3, doesn't that give me -27? So before, when we had negatives underneath our square root, we had no solution. But we're allowed to have a negative underneath the cube root because I need 3 negatives to give me a negative. So that does work. So anytime actually that I have a negative underneath an even root, a square root, a fourth root, a sixth root, and I have a negative underneath, my answer is no solution. There's never going to be a way that I can multiply an even amount of numbers to get a negative. But if I have a negative underneath an odd root, a cube root, a fifth root, a seventh root, then it is possible. I can figure out what number multiplied an odd amount of times to give me a negative. So negatives are okay when I'm talking about a cube root. Let's graph a cube root. We just saw what a square root looks like. Remember that breadstick? Let's see what a cube root of x graph looks like. Let's do the same thing. Let's pick a couple of x values, plug them in, find some ordered pairs, and see if we can find a pattern so we can graph what the cube root of x looks like. I strategically picked some numbers that worked out to be nice whole numbers so that I can use those to more easily graph. I chose x as -8, -1, 0, +1, and +8. I substituted in for x, and then I simplified. We know that the cube root of -8, that's okay, right? As long as it's an odd root, is -2. The cube root of -1 is -1. The cube root of 0 is 0. The cube root of +1 is 1. And the cube root of 8 is +2. So now I have a whole bunch of different ordered pairs that I can plot, and I can maybe see a pattern so I can sketch the graph of the cube root of x. I ended up plotting all of those different points, and I got something that looks like this. So kind of a little squiggly, I don't know, snake-like kind of shape. It looks like it's going to go in every direction. Remember, negative x's work now and positive x's work. So it looks like my domain is going to be all real numbers, or from -infinity to infinity. It looks like as x gets smaller and smaller and smaller, my graph's going to go down lower and lower. Maybe not as quickly, but it's still going to go down, 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 and hit all y values in the negative direction. And then it's going to go up, 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 slowly, 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 and hit all y values in the positive direction. So I can say that my range is also all real numbers, -infinity to infinity. Make sure you have an idea of what these two general graphs look like, the square root of x and the cube root of x. We're going to be talking a little bit more about graphs and functions of all different types of equations as we go through the class. So it's important that you have an idea of what those two graphs look like.